My throat is getting sore and sore, right? Mercy me. I've been here for, I told you already, my major has been focusing on stress. Do you feel stressed today? Maybe you do, all right? So I've been working on this slide for 40 years. I'm facing stress, environmental stress, biotic stress from planes for many years. Monday, I used microphone. Security guard went to the front door and said, what has been going on here? If I use microphone, the whole building will hear my voice. So lower down your voice. And then I can increase my voice. Right? You don't want to listen to do this. Or do this. Do this. Watch me. Do this. I don't care at all. I don't know why you are here so early. I don't know. So please, next question. Rest up. Please lower down your voice. Please. This is the university I come from, all right? Has somebody else been to my university before? No? Has somebody else been to Taiwan before? No? Okay. I told you, I've been here for 6 times. That was the first day. The first trip on this campus. I actually went to your library to teach your alumni, graduate students. Your classmates who graduated already. To use SAS in your library. And that's the only time. Why? If I do I'm seriously, I want you to run whole SAS input and explain the output to me. That took about 2 hours. So every student sat there was doing nothing. Maybe you don't understand my language or somehow some so forth. So from second year, I just taught you guys lessons and then those teaching assistants, what you saw those faculty members, lecturers teaching SAS. Who taught you SAS last summer? Kim or Jim? Kim, okay. Either Kim or Jim, both of them are in Taiwan now to pursue their PhD program. Alright? So no one will help me this summer. No one. I will help you with SAS. Alright? Second time. Third year. Alright? Last year. If you come to Taiwan to join the program called High Quality Program. In my university, we will train you all of this. Anyway, I was here again 2 months ago. All right, maybe you also participated the international symposium. Maybe you heard my talk. I don't know. All right, I was here. Where? Maybe I should turn off the. Can you help me with the lights? A little bit dark. Can you find me? The handsome guy? No? Okay. Okay, anyway. My throat getting hurt and sore just because I've been here for the third day, from Monday to now. I still have 2 more days to go. From 6 o'clock, 15 minutes. My goodness, you guys work so hard. In Taiwan, the first class begins at 9 o'clock, early morning, 9. You start at 6 o'clock, 15 minutes, 10 to 7. My goodness, OMG. So, listen to me. All right, hear me, voice. I need to protect my voice until Friday. assume that you want to do repeat. All right, welcome to come to my class again on Friday and Thursday, which is tomorrow and the day after tomorrow. It's your choice. All right. I told the same thing to Monday's class and yesterday's class. I don't know if anybody who will hear and hear again. Anyway, the morning session up to here. So about 11 o'clock, before class dismissed, you should learn all of this, especially teach test from me. All right, from 12:30 to 4:30, you should learn all of this from me, especially chi-square test. You don't know nothing about t-test and chi-square test so far because I did not teach you last summer. By the end of the day, if you don't understand t-test and chi-square test, you are ashamed. You are so shameful. All right. So please speak to me. Speak to me. All right. If your voice louder than me, I'm going to use microphone. And this guy sitting over there will stand up right there and watching me. Please lower down my voice. All right. It happens yesterday, so Monday. All right. So please. All right. You can raise up your hand and ask me a question. Welcome, but please understand my situation right now. All right. So not title, not objective. I'm trying to help you to do your experimental design. That will be very, very helpful for your graduate program. I believe maybe some of you, maybe few of you, will go to America, will go to Australia, British, or even French, to pursue your master's, even PhDs. Then experimental design will become very, very important. If you just graduate from here and work, experimental design is not important. Alright? So stick to me. If you want to pursue your higher education in anywhere else, even in Vietnam, on this campus, experimental design will be your top topic. Your top topic. Totally be honest with you. And after design, you collect all your data and then analyze your data by SAS. That's the two major topics, related topics that I'm going to deliver to you today by 4:30. All right. And the end of today, all of these comments, all right, univariance means frequency, correlation, blah, 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 up to GLM, you learn from me. For sure. All right, so stick to me, please. Since you know SAS already, all right, from last summer, from Kim or from Ching, whosoever, all right, so you're so lucky. Let me start from, okay, for the first half hour, I would like to refresh your memory from last summer, all right? Then I'll go to the new materials. Data, remember I talked about this. Data analyzed by SAS. What is data? What are data? How can you collect data? Where are data? All right? Everywhere. Listen to these statements. Those are data. And be honest with you, this data here is garbage data, trash, junk. When you hear statement like this, increase from blah, 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 all right? Trash, don't trust the data. Those are stupid data. Same thing here, this is stupid data. Why? Why this? Oh, the data can be worse. The data can be like this. Figures, tables, right? Data without last summer, the most important two symbols are this. This year, two. I'm going to put this right here. And then the end of semester, the end of class, you look at these parameters and you realize how important these parameters are, right? Anyway, the whole concept for today is last year's even in your future, will be the formula right there. This figure just tell you average here. Average without standard deviation. This average data is junk. This data, 21% is mean. Use this. It just tell you the truth. But the truth is not based on statistic analysis. Without standard deviation, this average is not useful, all right? So, read the statement again. There are 1,000, 10,000 TDT university students or Vietnamese, all right, suffered from cancer disease whatsoever. When you hear a statement like this, don't listen. Don't listen. 1,000, so what? 10,000, so what? 10,000 of what? The total population. So this information just give you sample. All right. Now read the message from the bottom sentence right here. Right here. Do you see this? What does that mean? Percentage. Right here, percentage. Divided by total number. To get percentage. Hey, this is so-called one of the most simplest statistical analysis. So if you hear percentage, you may trust it. Without calculation, without statistical analyzed calculation, the data itself is raw data. Raw data means garbage data, trash data. Do not trust. All right. So this sentence here, this statement here, trash, throw away. But when you hear like this, 95% are male, 48% are male, 87.999 are male. Excellent. It has been through calculations, statistical analyzed, and then you get a percentage. Great. Statistical data. Statistical means calculated by analysis, which is division over there. One more time. Read this. 20 high blood pressure patients. So what? 20 is right here. 20 or what? 20 students from ATT University, from Ho Chi Minh City. Yes. But it doesn't say like that. It only say 20 samples. Can sample be treated as population? No way. No. All right? But when you hear like this, 48.999, 84.777, whatsoever, hey, this percentage information has been calculated by statistical analysis. Right there. So this is informative data. Percentage data has been calculated. All right. So it's so-called informative data, which is good. So you may trust this data. Do not never trust the 20 students' data. No way, Jose. All right. Do you know who she is? Angelina. About 4 or 5 years ago, she got breast cancer from her medical doctor. Her medical doctor told her that, hey, Angelina, you had 87% of the risk to get breast cancer. 87%. Did I tell you that this percentage data has been calculated by statistical analysis? In other words, 100 women who suffer from breast disease will be died. Do you think she was a crazy woman? She was so stupid to remove her boo-boos? No. Her mother got breast cancer genes. inherited to her. Trust those medical data. Those are medical data from whole population. In the whole wide world, 87% of human beings will be died from this, breast cancer. So she immediately asked the doctor to remove her breast. Of course, put silicone back to the breast. All right? Do you remember the movie Mr. and Mrs. Smith? So she got married with, Brad Pitt, but they divorced. They are separated, divorced already. Anyway, that's the story. The story tells you about this. It's trustworthy. This data can be trusted. All right? Now, data. 20, data, percentage, data. So data is everywhere, all right? But the data, you need to collect it. You need to analyze it, all right? All information here is based on science. You collect your data, all right? You design your research, collect your data, and then you analyze data. All this procedure here is evidence-based scientific research. All right. So you need to know what is this? Science. Science means evidence. Without evidence, it can be called science. So when you go to your master's, PhD programs, get this picture out again. Your advisor asks you to do a research, science-based research or evidence-based research. Then remember what I said today. Start from making hypothesis, and then design your study. Experiment design. After your experiment design, you collect your data, and then you analyze your data, and then you explain your data. Then you graduate with a master, with a PhD. Then you will be called Dr. So-and-so. All right? So maybe this picture will reflect your whole life. Maybe, hopefully. All right? So you are senior year now. You're a senior student, right? The fourth grade, the fourth year in this university. Next summer you will be graduated. And as I said, few of you, some of you will go to summer to pursue your master's. This is very important. Very important. So I will deliver all concepts, all of them, to you by 4:30. So stick to me, please. If you don't like me, don't understand me, woo-hoo. Play with your video games. I don't care at all, right? So, let me translate. You know my style. I show you some pictures for clearance. I show you this, and then I show you this. I show the concept of science by figures, by tables, and then I show you by words. So this one and previous one, even the next one, are all related. So you are my repeated student to me, all right? So you got to understand my personality and style, all right? So how do you do the statistical analysis? First step, making hypothesis, all right? Then do experiment design, collect data. Now the problem is, how will you collect your data? Think about it. Your professor, the future professor, asks you to collect your data after making hypothesis and experiment design. Go to somewhere. Go to a rice farm, orchard, all right? Any kind of garden to collect those plants, insects. How do you collect your data? Keyword, random sample data, all right? And this slide has been shown in your lecture notes from last summer. As I said, the first lesson about 30 to 50 minutes is a refreshment. from your memory, all right? So, what are random samples? Two keywords again. Those numbers, those materials, starting materials, subjects in the field, in the garden, in a farm. Those samples are two words, are independent, and each subject should be chosen equally, right? Those keywords, equally changed, independent, finish. So when you select your study materials, subjects, stick to two concepts, all right? Random sample, which can include equal chance of samples, independent samples. All right. What is the meaning of equal chance? Same thing goes to what is the meaning of independent samples. Go back to your lecture notes. From me, all right. From me, my lecture notes last summer. All right. Read this again. Mean means true value. Sigma, all right? Mu is mean, which is true. This is so-called bias, all right? So when you read like this, you ask yourself, how do you get this bias data? How? If you get a higher standard deviation, that means your research is having some problem with errors. Where are errors from? Where do errors come from? From human errors, from God, from environment, from machine, technical problem errors. So errors can be anywhere. Once you have bias data, it must be coming from some sources. So this random errors is so-called unknown errors. Unknown. Maybe some of them are known. Unknown sources. All right. So put it down. I'm so glad to see you get my lecture print out. All right. Thank you very much for your attention to print out my lecture notes. So put this word in your lecture notes. Random errors means unknown source. Unknown. You don't know. Unknown sources. You have no idea. All right. If you know, then this will not be existing anymore. No standard deviations. If you don't have standard deviation, it means that you have no errors. But it's not true. The truth is, you always have standard deviation data from sample itself. I told you to do 5 repeats, but you don't have time. You are out of your study material, so you only do 2 repeats. Even if you don't take any repeats, then you got standard deviations. All right. So I'm going to give you more and more ideas about those 2 parameters: mu, true meaning, true value, and then standard deviation, especially standard deviation. And standard deviation comes from unknown sources, which is so-called random errors. What is this? Descriptive statistic means this. The whole thing here is so-called descriptive statistics. And then let me ask you a question again that I asked already last summer. Is this sample average is this sample average close to population average? You have no idea about the population average. Impossible. The whole population size is over 1 billion of human beings. There's no way you can know the mean. average from population. However, when you do the random sample, you may obtain the sample average. Now the question is sample average equals to population average? Listen to me, equal to? No, impossible. But you can say like this. This sample average 22 is close to population average. Yes, close. What does that mean? Close. The meaning of the close is called estimation. Estimate. All right. So when the statement goes like this, is the average, the sample average, close to population average? This whole thing is so-called inferential statistic, or say statistical analysis, statistical inferences. All right. So two different levels over there by hand calculations, and then you obtain the data like this: mu plus minus sigma, which is so-called descriptive statistics, and this one right here, estimation. Later on, I will show you. Estimation means CI, confidence interval, or say CL, confidence level. All right. Read the question again. I showed you this slide 10 minutes ago. Raw data, informative data, sample population. You infer the sample average into population average. It's called inferential statistics. Finished. All right. So one more time, statistical inference comes from sample. Using the sample information to infer the information of the population. All right. Once again, the whole concept about inferential statistics is about two things: testing, hypothesis testing, and CI. Remember I said that estimation. Estimation means CI. CI means close. CL, estimate. What does that mean? Estimate, predict. You predict 22 close to 22. Predict means 95% right, 5% wrong. All right. So they are all related, and you will be learned from me today. All right. So anyway, so the whole concept about the inferential statistic is number one, hypothesis testing. Number two, CI value, CL value, same thing. One more time, read that. Two parameters over there. Center, true value, center. All right. The sigma, spread out. All right. The whole slides, over the previous slides are copied from this textbook. All right. If you want to get this textbook for free, email me. I just use email. Send you the whole book, 682 pages. I just give it to you. I will be violating the copyright, right? But when you email to me, I have it sent to you. Do you understand me? Good. You email me. I send you this book as free sources. All right? Because I use this book, I spent my money to buy this textbook, and I'll give to you for free. But you need to email. All right? I told you the same thing again. Last summer, nobody want to email me. So, still in my computer, right? All the lecture notes, most of the slides are from this textbook, got so old. Do you have American dollars? No? Look at this. And look at me. You are the best. Always trust yourself. You are the best of the best. Alright? Any questions so far? Hey girls, you may talk now. No? No, please shut up. Alright? Now, how do you study SAS? Or say, how do you do your data analysis? Alright? Like this. I did this already. Yes. That was your first question, take-home exam question from that summer. Alright? So, you know how to do it by using SAS. Hey, this data set are only 50 students. What about 500 students? What about 5,000, 50,000, 1 million data? You cannot use your hand calculations anymore. You must use SAS or any kind of statistical analysis software. Alright? There are so many softwares that you can use. Of course, Excel. Do you think Excel can handle 4 million data set? 4 million. Oh my goodness. Impossible. But only one software can handle 4 million data set. For instance, airline company, they have their passengers data for over 40 years, 50 years. Do you know what kind of software they use to save passengers' information? SAS. I have my graduate student who worked in the China airline. He told me that, thank you teacher, you helped me with SAS. I'm now sitting in the front desk of China airline to use SAS to call out the passengers from 11 years ago. 11 years. They had a system, a kind of internal system or whatever suspect in China airline. They know your personal data. Where do you live? How much money have you been paid? Whatever personal data. SAS. It's so powerful. So far. Maybe the other, for medical training, they prefer to use BMPP. This is good for human beings analysis, drug analysis, right? So anyway, I'm not a medical doctor, so I don't need to know BMPP. I know this one, it's good enough for my own research, and I hope you do the same thing again, right? I don't want to go through this because you have learned something from me and from Jack Ching or Kim, all right? So this has been learned from me, from your lecturer last year. Just refresh your memory. Proc univariate. Why? Because only one variable. Only one unit means mono. One variable. Only one variable, which is scores, points, grades, 85 points, 99 points, 59 points, so on, so forth. Only one, right? You don't like this input, you may try this input. All right, so you have been learning this already. So I don't want to go through all of this. All right. So this slide shows you the background story about input. VAR means variables. Proc means procedures. Blah 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 blah. All right. You knew this already. What should I spend? Waste your time. All right. That's your output, and you explain this output to me already, or to Kim already last summer. All right. So why bother to learn more from me? You know this already. All right. All this information, for instance, median, standard error, mode, variance, mean, standard deviation, so on and so forth. You have noticed from that summer, mean, median, mode, all right? Standard deviation, variance, blah, 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 blah. Oh, by the way, is any one of you has any one of you been using the command infile? No? To me, I use infile all the time. I ask my graduate students to key in the data for me, and save in his Excel or his USB, and then send a message to me. And the file name of the message, the file name of the data set is called grade 1. So I infile the data set from my graduate students. Infile. In other words, I'm too lazy to type up all this information. So I ask my graduate student to type up this information for me in his home or in library. Send the data to me using Excel or any kind of data software. Then you use infile to save your time, all right? But if you don't know how to use infile command, that's okay. You just type from 74 to 63, all right? Because you are on your own, you don't have any people who can help you. Fine, you just waste a little bit of your time, but you learn. To me, I don't have time to do this, so just ask students to send me all the packages. That's why I use infile all the times. All right? So one more time, ask me about the sums. All right? I just finished the first lesson. All right, let's move to second lesson, t-test. Before I go to t-test, I just show you this. All right? T-test is a test of statistical analysis. So you need to know. Oh my goodness, what's wrong with this? Can somebody else tell me? It shows here, but not there. Please. Come on, guys. One of you show up, please. It's written in Vietnamese. I don't understand this. Hey, girl, come. Face this direction for me. Right here. It shows right here, but not here. Why? Help her. Go get help. Don't smile. Go get help. Go. Call your director. Call somebody else. Help me. It's so-called technical problem. I don't understand. Where's the security card? Nobody can help me? This is your school. This is your university, not mine. Come on, do something for me, please. Call. Or find somebody else for me. Hey, sir, can you help me with this?